Have you ever wondered how rockets break free from Earth's grasp? It's a question that has fascinated scientists and dreamers alike for generations. It's a powerful force, this gravity. It's the invisible hand that keeps us grounded, making sure we don't float away into the vast expanse of space. It holds us to the ground, keeps our atmosphere in check, and even dictates the motion of the moon. Without gravity, life as we know it would be impossible. To escape Earth, rockets need a tremendous amount of power. This power is generated by the rocket engines, which burn fuel at an incredible rate to produce the necessary thrust. That initial boost you see at launch, it's the most critical phase of the journey. That's about breaking free from gravity's grip and starting the journey to space. Imagine trying to throw a ball so hard that it never comes back down. Think of it like throwing a ball upwards. The harder you throw, the higher it goes. The harder you throw, the higher it goes, right? But to reach space, you'd need to throw it at a speed of about 25,000 miles per hour. Rockets work in a similar way, but on a much grander scale. They need to reach what's called escape velocity to break free from Earth's gravitational pull. They need enough power to overcome Earth's gravitational pull, which is no easy feat. This requires precise calculations and immense engineering prowess. This is why rockets are so massive and their engines are so powerful. Every component is designed to maximize efficiency and power. They need every ounce of energy to escape Earth's grip. The fuel they carry is a mix of liquid oxygen and hydrogen, which combusts to produce the necessary thrust. But it's not just about raw power. The design and engineering of the rocket play a crucial role in its success. There's a lot of science involved in choosing the right location, the right time, and even the right path to reach orbit. The launch site is selected based on its proximity to the equator, which provides an additional boost from the Earth's rotation. It's a delicate dance between physics, engineering, and a touch of human ingenuity. The trajectory must be meticulously planned to ensure the rocket reaches its intended orbit. So, buckle up as we delve into the fascinating world of rocket science and unveil the secrets behind launching into the cosmos. From the initial spark of ignition to the moment it pierces the atmosphere, every second is a testament to human achievement and the relentless pursuit of exploration. Believe it or not, Earth's rotation plays a crucial role in space travel. You see, our planet is constantly spinning, and this spin generates a centrifugal force. It's the same force you feel pushing you outwards on a merry-go-round. Now, imagine harnessing this force to give your rocket an extra push. That's exactly what rocket scientists do. By launching rockets eastward in the direction of Earth's rotation, they get a little speed boost. It's like getting a running start before jumping. This free boost from Earth's spin helps rockets save fuel and reach orbit more efficiently. This is why most rockets launch towards the east. It's not just a random choice, it's about working with nature, not against it. It's a clever way to leverage the laws of physics and give our spacecraft an edge in their journey to the stars. Now, if launching eastward gives rockets a speed boost, where do you think the biggest boost comes from? That's right, the equator. The equator is the fattest part of our planet, the point where Earth's rotational speed is at its maximum. This means rockets launched from the equator get the biggest possible push from Earth's spin. Think of it like this. The closer you are to the center of a merry-go-round, the slower you go. The further out you are, the faster you spin. The same principle applies to Earth's rotation. Equatorial launch sites provide that extra speed boost, making it easier and more efficient to reach orbit. Of course, not every country has easy access to the equator, but for those that do, it's a significant advantage in the space race. It allows them to launch heavier payloads, reach higher orbits, and explore further into the cosmos. Section 4. Coastal launches, safety and efficiency over the ocean. You might have noticed that many spaceports are located near coastlines. There's a good reason for that. Launching over the ocean offers several advantages. Firstly, it's a matter of safety. In the unlikely event of a launch mishap, debris is less likely to land on populated areas if a rocket launches over water. Secondly, coastal launches provide clear flight paths. With no mountains or tall buildings in the way, rockets have a straight shot into orbit. This reduces the risk of collisions and makes the launch trajectory more efficient. Finally, launching over the ocean allows rockets to take advantage of the Earth's rotation for that extra speed boost we talked about earlier. By launching eastward over the Atlantic Ocean, for example, rockets get a little extra push from our planet's spin. Section 5. Florida's Space Coast, a balancing act of location and weather. When you think of rocket launches in the United States, Florida's Space Coast probably comes to mind. But why Florida? What makes this location so special for space missions? Why not, say, California or Texas? These states also have significant space facilities and have seen numerous launches. Well, Florida's location offers a unique set of advantages for space exploration. Its geographical position is a key factor. As we discussed earlier, launching eastward near the equator is ideal for maximizing the boost from Earth's rotation. This rotational boost is crucial for achieving the necessary velocity to reach orbit. Florida's location on the southeastern coast of the United States puts it in a prime spot for eastward launches over the Atlantic Ocean. This means rockets can take full advantage of the Earth's rotational speed, saving on fuel and increasing efficiency. This geographical advantage makes it possible to reach a wider range of orbits with less fuel. The open expanse of the Atlantic Ocean also provides a safe area for rocket stages to fall back to Earth, minimizing risks to populated areas. However, Florida is not without its challenges. The weather here can be quite unpredictable. The Sunshine State is known for its unpredictable weather, including frequent thunderstorms and hurricane season. These weather conditions can be a significant hurdle for space missions. These weather patterns can delay launches and pose risks to missions. During hurricane season, extensive preparations are made to protect the facilities and equipment at the Kennedy Space Center. Nevertheless, the benefits of Florida's location outweigh the challenges, making it a strategic hub for space exploration. The combination of its geographical advantages and the infrastructure in place at the Kennedy Space Center ensures that Florida remains at the forefront of space exploration in the United States. Historically, Florida has been the launch site for many significant missions, including the Apollo moon landings and numerous space shuttle launches. This legacy continues today with modern missions to the International Space Station and beyond. The Space Coast is not just a launch site, it's a symbol of human ingenuity and our quest to explore the cosmos. Each launch from Florida brings us one step closer to understanding our universe and reaching new frontiers. The dedicated teams of engineers, scientists, and support staff at the Kennedy Space Center work tirelessly to ensure the success of each mission, overcoming the challenges posed by weather and other factors. In the end, the balancing act of location and weather is a testament to human perseverance and the relentless pursuit of knowledge. Florida's Space Coast will continue to be a beacon of space exploration for generations to come. Section 6, Up, and Away, the logic of vertical launches. You might be wondering why rockets launch straight up if their goal is to orbit the Earth. You'd think they'd launch horizontally to follow the curvature of our planet, right? Well, there's a good reason for that initial vertical ascent. Remember Earth's atmosphere? It's great for breathing and protecting us from harmful radiation, but it creates drag and resistance for rockets. By launching vertically, rockets can quickly ascend through the thickest part of the atmosphere, minimizing friction and saving fuel. Think of it like swimming through honey versus swimming through water. It's much easier to move through water because it's less dense. Similarly, rockets can travel more efficiently through the thinner air of the upper atmosphere. Section 7. Gravity's turn bending the trajectory for orbit. So if rockets launch vertically, how do they end up orbiting the Earth? This is a fascinating question that delves into the intricate dance between engineering and physics. This is where the concept of gravity turn comes into play. The gravity turn is a critical maneuver in rocketry, designed to optimize the path of the rocket as it ascends. After a rocket reaches a certain altitude and speed, it performs a gradual tilt, steering itself towards a horizontal trajectory. This tilt is not random, but a carefully planned maneuver. This maneuver is carefully calculated to use Earth's gravity to help bend the rocket's path towards orbit. By doing so, the rocket can take advantage of the planet's gravitational pull to assist in its journey. Imagine swinging a ball on a string. This simple analogy helps us understand the complex forces at play. As you spin, the string pulls the ball inward, curving its path into a circle. The tension in the string is akin to the gravitational pull that the Earth exerts on the rocket. Gravity acts in a similar way on a rocket during a gravity turn, pulling it towards Earth while its forward momentum keeps it moving. This balance between gravitational pull and forward momentum is essential. This delicate dance between gravity and momentum is crucial for achieving orbit. Without this precise balance, the rocket would either fall back to Earth or drift off into space. It allows rockets to efficiently transition from a vertical ascent to a circular path around Earth, conserving fuel and maximizing their chances of a successful mission. This efficiency is not just about fuel, it's about ensuring the payload reaches its intended destination. Engineers spend countless hours planning and simulating these trajectories to ensure that every launch is as efficient and safe as possible. The gravity turn is a testament to the precision and expertise required in space travel. Historically, early rocket launches were more about brute force, but as our understanding of physics and engineering evolved, so did our techniques. The gravity turn represents a significant advancement in our approach to reaching space. Today, every modern rocket employs this technique, showcasing the blend of human ingenuity and natural forces. The gravity turn is a perfect example of how we harness the laws of nature to achieve our goals. Once in orbit, the rocket can perform its mission, whether it's deploying satellites, conducting scientific experiments, or even preparing for interplanetary travel. The journey to orbit is a marvel of modern science and engineering. As we look back at Earth from space, we can appreciate the incredible journey that began with a simple vertical launch and culminated in a precise, stable orbit. The gravity turn is a crucial part of this journey, bending the trajectory for orbit and making space exploration possible.